math. Today we're going to be talking about multiplying fractions by whole numbers. We're going to do it with tools and without tools, and we are also going to need to talk about regrouping. All right, let's dive in. Charlene has 5 1-pound bags of sand, each a different color. For an art project, she will use 3/8 pound of each bag of sand to create a colorful sand art jar. How much sand will be in Charlene's sand art jar? For this, we're going to need to multiply a fraction by a whole number. We're going to do 5 times 3/8 because she's using 5 different colors. So to do this, we can shade a model. Okay, so shade the model to show 5 groups of 3/8, and they show us that here. Okay, and they want us to do that 5 times because remember, multiplication is just like repeated addition. So I'm going to get the highlighter tool out, and I'm going to very carefully shade these very tiny areas, but I need to shade 3/8 of each of them. So I'm going to shade the bottom 3 of all of them. 3, 3, 3, 3, and 3. So just like that, we have 3/8 shaded in 5 different bars, okay? Now, the second step tells us to rearrange the shaded pieces to fill as many holes as possible. That was really confusing for me when I first was looking at it, but what they want you to do is kind of just drop all of those into 2 bars. So I'm going to do it piece by piece. So the first one here, there are 3 in this one, right? So I'm going to shade in 3, and that takes care of that bar. Check it off. The next one has 3 more. I'm going to shade in 3 more. Check it off. 3 more. Well, this one only has 2, so I'm going to do 2 here and 1 here. Check this one off. We have another one, so 3 more. Check it off, and then 3 more. And we've got almost a full bar there. Check it off. Now, what we're doing is we're just combining all of them to see how many holes we have, okay? So you can see, let me change my color here. Excuse me. We have 1 hole shaded in here, but then the second one wasn't all the way shaded. There were 8 pieces to begin with, so that's our denominator, and only 7 of them were shaded. So our answer is 1 7/8. Now, I kind of jumped ahead there because it's so easy to see that, but it would also be equal to 15/8 because there are 15 of those little slots shaded in, okay? So 15/8 is an okay answer. It's an improper fraction, so it's not the best, but 1 7/8 is in its simplest form, so it is the best answer. So there are 1 7/8 pounds of sand in Charlene's sand art jar. Now, if we come back over here, we can go back and answer this part very easily now. So how much sand was in each bag? It was 1 pound, LB, okay? Will Charlene use all of the sand in each bag? No, because 1 pound, LB, is greater than 3/8 of a pound. 3/8 of a pound is only part of a pound. So it's clear that 1 pound is more than 3/8 pound. So they ask us to write the expression, which is here, 5 times 3/8. It was also over here. And then it says multiply the number of 8 size pieces in each hole by 5. Then write the answer as the total number of 8 size pieces. That's confusing, right? It's the wording, really. So what they want us to do is 5, because we have 5 bags of sand, and then 3/8 would be here. That's the same as that fraction there. So 5 times 3 is 15, and the 8 slides over because our size never changes. So our answer, again, meets up with what we had over here, 15/8. So then if we come back down here, we can write it 15/8, and we were already quick enough to do 1 7/8, okay? As you're working through these, if they're really hard, I want you to just try your best. Ask somebody around you for help. If nobody's around to help you, get a hold of me during my office hours. I would be more than happy to help you. All right, let's carry on. Kristen brought in 4 loaves of sliced bread to make sandwiches for the class picnic. Her classmates used 2/3 of the bread. How many loaves of bread were used? Now, this one's a little bit different. It says shade the model to show 2/3 of 4. They're not broken up for us yet, so we have to be pretty careful. Take a look at the denominator is 3. So we need to split all of these into as close to 3 equal pieces as possible. This is my least favorite part about fractions because in some cases it is so hard to be as equal as you can. So that's as equal as I can get by writing on my computer. Each one is divided into 3 pieces and they're pretty close to being equal. Now, for each one, I need to shade in 2 of them because it's 2/3. So we'll do 2 here. 1, 2. I need to switch tools. There we go. 1, 2. 1, 2. 1, 2. 1, 2. Okay. Now, just like we did in the last one, we need to kind of combine all of them. So I'm going to switch back to this, and I'm going to first split these all into thirds the best that I can, as equal as I can. Oh, that one's not very good, but that's okay. All right, now we're just going to start to combine all of them to see how many whole loaves of bread her classmates use. So, like I did before, I'm going to just start at the top and I'm going to color in 2. 1, 2. I need to change tools again. There we go. 1, 2. That takes care of that one. Now the next one, I'm going to do 1 on this top one and 1 on this bottom one. So 2. That takes care of that one. Now the next one is 1, 2. That takes care of the third one. And the last one would be 1, 2. So how many loaves of bread were used? I see a whole loaf of bread was used here. A whole loaf of bread was used here, and almost a whole loaf of bread was used here. So I have 1, 2, and there are 2/3 filled in on that last one, so it's 2 and 2/3. Okay. Now you're going to see this one again as an improper fraction because if we count the first one, it's 1, 2, 3. The second one would be 4, 5, 6. And then the last 2 would be 7, 8. So it could also be written as 8/3 as an improper fraction. Okay, so if we come back up to the top, we have write it as an expression to represent the problem. We have 2/3 times 4, which was back over there. And it says multiply 4 by the number of third size pieces in each whole. Then write the answer as the total number of third size pieces. Again, don't let the wording confuse you too much. They just want you to do the multiplication like we did before. There were 4 loaves of bread and 2/3 of it was gone. So we're going to put 2 on the top and 3 on the bottom. That 3 is going to slide over and then we can multiply 4 times 2. 4 times 2 is 8, and that matches that. Okay, so we're on the right track. Then the next one says write the answer as a mixed number. Well, 8/3 there, and then we were already able to put it into a mixed number when we looked at the model. So we have 2 and 2/3. Now I want to show you real quick another way that you can do this. 8/3 we can do without a model simply by subtracting wholes. So because the denominator is a 3, a whole would be 3/3. Now 8 minus 3 is 5. That's still an improper fraction, so we can subtract 3/3 again. And 5 minus 3 is 2, and we have 2/3, so that's good. Now, when we do this, you have to count the number of holes that you had. So we had 1 hole, 2 holes, so we have a 2, and then our leftover fraction would be 2/3. This is a fine way of doing it. When it gets to be a really big improper fraction, it's going to take up a lot of space, so it's not always the most effective. But if you like that idea and you like circling, that's how I learned it as a kid. All right, let's carry on. Now, let me show you, before we move on to no tools, how you could do this with the fraction tile. So let me go back a slide, and we'll do 2/3 times 4 again. Now I'm going to put these up here, okay? 2/3 times 4. So I'm going to go 1, 2, that's 1. 1, 2, that's 2. 1, 2, that's 3. 1, 2, that's 4. So you can see that we have 1, 2 holes that are completely filled in, and then we have an empty space right here. So it is 2 and 2/3, which is the exact same answer that we got here, 2 and 2/3. We can do the same thing for this one, 5 times 3/8. Let's go back to this. 5 times 3/8. Let me get rid of all these thirds. And we're going to do 5 times 3/8. So 1, 2, 3. That's 1. 1, 2, 3. That's 2. 1, 2, 3. That's 3. 1, 2, 3. That's 4. 1, 2, 3. That's 5. I can take this one away because we didn't need it. And I can see that 3/8 times 5 gave me 15/8, which is equal to 1. And we have all but 1 right at the very end there, 1 and 7/8, which is the exact same answer that we got here. You can feel free to use this fraction tile tool anytime you want. It'll be in the link for the lesson, okay? All right, let's head back to here. Now, I'm going to show you a shorter way of doing it without tools if you feel like you're ready to do it without tools, okay? It does say find the product and write it in simplest form. And simplest form just means that you've reduced the fraction down to a simple fraction that can no longer be made smaller, and I'll show you what that means. So when you have 4 times 7/8, you can do it like they were showing on the previous page, where you do 4 times 7 eighths, right? Now it's all in eighths already, so we're going to leave it right there, okay? Now we do 4 times 7. 4 times 7 is 28, and that's an improper fraction, so we need to put it in simplest form. Now, like I was saying before, you can stretch it out, okay? So we're going to do 28 eighths minus a whole, which would be 8 eighths, okay? 28 minus 8 is 20. Now we're left with 28. It's still an improper fraction, so I'm going to subtract another whole from it. So minus 8 eighths, and 20 minus 8 is 12. Now we're left with 12 eighths. 12 eighths is still an improper fraction, so I'm going to subtract 8 eighths again, and now I get 4 eighths. 4 eighths is not an improper fraction, so I can stop there. And the very first thing I'm going to do is I'm going to count my holes. I have a hole here, a hole here, and a hole here. How many holes are there? 3. 3 holes, and then what's left over just gets slid down, so 3 and 4 eighths. Okay? Now, hopefully you are saying to yourself, Miss Witkowski, 4 eighths is also 1/2. You would be correct. You can change that to 3 and 1/2. Okay? Guess I should keep my fractions the same. 3 and 1/2. If you notice that the top number and the bottom number have a relationship, like for example, both of these can be divided by 4. 4 divided by 4 is 1, and 8 divided by 4 is 2. It's 1/2. Okay? All right, let's look at the next one. 5/9 times 12. Now, this is where this stretched out version is going to get kind of redundant, and it's going to take up a lot of space. And so you're going to want to make sure that you either have a lot of space to work it out and are not making any mistakes, or you can dip into your division knowledge and do it that way. I'm going to show you both, okay? Let me switch colors. I'll do this one in green. So 5/9 times 12. We do it the same way. 5/9 times 12. It all goes on the top. And hopefully you haven't forgotten your 12's multiplication, but 5 times 12 is 60. Okay? Now, 60 is a big number. Big number. Okay? We're going to be doing a lot of circling holes. So what you can do is you can ask yourself, what would 60 divided by 9 be? Now, you're not always going to get a perfect answer here because you're hopefully saying, Ms. Wachowski, 60 is not divisible by 9 in a clean way. It's going to have a remainder, and that's a good thing. So I'm going to count by 9s until I get pretty close to 60, okay? So we have 9, 18, 27, 36, 45, 54, 63. All right, 63 won't work because it's too high, right? But 54 will. So what I can do is I can do 1, 2, 3, 4, 5, 6. There are 6 holes in this multiplication problem. So I'm going to write a big 6 down here. Then what you have to do is take 6 times 9, which gives you that 54, and we're going to subtract it from 60. And 60 minus 54 is 6. So we have 6 and 6/9. This subtraction is going to give us our new numerator, 6/9. Now, this is a good answer. There is a simplest form for this. I know, based on my multiplication knowledge and my knowledge of multiples, that 6 and 9 are both divisible by 3. So if I do 6 divided by 3, I'm going to get 2. And if I do 9 divided by 3, I'm going to get 3. So my simplest form would be 6 and 2/3. Okay? Now I know that this can be confusing, and I've hopefully given you some tools that you can work with. But if you have any questions, get a hold of me. Totally get a hold of me. I can video chat with you. I can talk with you on the phone. I can text with you on Gmail. And all of those I can hopefully help you through. Okay? Now let's take a minute and look at simplest form. I've said it a few times, and I want to make sure that you understand what simplest form is. So when I look at 3/15, I can see that both of these numbers are divisible by the same number. You know what that number is? Hopefully you said 3. So 3 divided by 3 and 15 divided by 3. Remember, when you're working with fractions, whatever you do to the top, you have to do to the bottom. Whatever you do to the bottom, you have to do to the top. Okay? Just make sure you don't forget that rule. So 3 divided by 3 is 1. And 15 divided by 3 is 5. So 3/15 is also equal to 1/5. Let's look at the next one that says 9/18. 9 and 18 can both be divided by something. Do you know what it is? It's 9. 9 divided by 9 is 1, and 18 divided by 9 is 2. So 9/18 is equal to 1/2. Now, any fraction where you see the numerator is half of the denominator, that is 1/2. Let's look at the next one. That's 12/4. 12/4. What are both of those divisible by? Well, this one is a little bit different. If I divide the numerator by 4, I get 3, right? But that 3 is going to become a whole number. 12 divided by 4 is 3 with no remainder. So the whole transition turns it into 3 wholes. So 12/4 is actually equal to 3 wholes. And I can show you that right quick with a little diagram. 1, 2, 3, 4. And if we divide them into fourths, and then shade them in threes, we have 1, 2, 3. That's 1. 1, 2, 3. That's 2. Or if you look, it's also 6/4. 1, 2, 3. We now have 9/4. 1, 2, 3. We now have 12/4, and look, it's actually made 3 wholes. Okay, kind of like what we were doing a couple slides ago. All right, let's take one last look at the last one. It's 10/15. Both of these can be divided by the same number. What number can they be divided by? Hopefully you said 5. So we'll divide 10 by 5, that equals 2. And if we divide 15 by 5, that equals 3. So 10/15 is equal to 2/3. All right, I've got one last slide. Equivalent fractions. Equivalent fractions are fractions that have different numbers but represent the same amount. So if we have 1/4, and I'll do my best to draw fourths here, it would look like this, right? And I'm going to shade in one of those. That's 1/4. Now I can multiply those by 2, and what that means I'm doing is I'm splitting each piece now into 2. And 1/4 now split into 2. How many pieces are yellow? 2. And how many pieces total now are there? 8. Now I could take this even a step further, and I could split each one of these into 2. Gets a little sloppy on a platform like this. But if I multiply each of these by 2, I now have 16 pieces. And how many are shaded in? 4. Okay? Another way that you can do it is you can do 1/4, multiply both of them by 2. You'd get 2/8. You can also multiply both of them by 3. Let me separate this. And you would get 3/12. Because 1 times 3 is 3. 4 times 3 is 12. If you did them both by 4, you would do 1 times 4 is 4. And 4 times 4 is 16, which is the same as that one there. You could even go up to 5. 1 times 5 is 5. And 4 times 5 is 20. So 5/20 is the same as 1/4. You could do times 6, because I have a little space left over. 1 times 6 is 6. And 4 times 6 is 24. So 6/24 is also equal to 1/4. Let's try 2/3. 2/3. Let's multiply both of them by 2. 2 times 2 is 4. 3 times 2 is 6. 4/6 is equal to 2/3. Let's multiply them both by 3. 2 times 3 is 6. And 3 times 3 is 9. Let's multiply both of them by 4. 2 times 4 is 8, and 3 times 4 is 12. Let's do a couple more. 2 times 5 is 10. 3 times 5 is 15. Ah, I saw that on the last page. Let's do another. 2 times 6 is 12. 3 times 6 is 18. You can even go all the way up to 100. So 2 times 100 is 200, and 3 times 100 is 300. 200 300ths is the same as 2/3. Okay, let's try 5/8 now. Let's start with 2 again. 5 times 2 is 10. 8 times 2 is 16. 10/16 is the same as 5/8. Let's try times 3. 5 times 3 is 15. 8 times 3 is 24. Let's do another. 5 times 4 is 20. 8 times 4 is 32. So 20 30-seconds is equal to 5/8. Let's do it one more. 5 times 5 is 25, and 8 times 5 is 40. If you'll notice when you set these up, you're counting by multiples. The multiples are just going across the screen. And then you could go all the way again to hundreds. You could even go up to thousands. 5 times 1,000 would be 5,000. And 8 times 1,000 would be 8,000. So 5,000 8,000s would be equal to 5/8. It's actually pretty cool when you play with the patterns. I suggest if you have some time, try it. Okay? I hope you got something from this lesson. Again, if you need help, please, please, please reach out and I will do my best to help you. All right, good luck.